The next measure of central tendency that we're going to talk about and that you hear often is the standard deviation. And the reason we hear that so much is that in research we talk about the number of standard deviations that a certain intervention has caused scores to improve. But we use it as a measure of central tendency, and what it really means is how far that the scores deviate from the mean. It's useful when comparing sets of scores that are ways of interpreting student scores. The larger it is, the more variable. You can see there how the bell curve flattens out when there's a large standard deviation, and the smaller it is, the less variable the performance. So that really is a way to say there's a large standard deviation in these scores, which means that they spread way out. That would tell you that, wait a minute, something's wrong here, that if everybody is not scoring either in a certain area where they should be, that something is wrong with either the test or the way you're teaching. So that's just a little bit about it, about standard deviation. When we type about test results, typically we don't talk about raw scores, although some people think those are better sample of results. We talk about percentage scores, usually in the classroom, how many somebody got right. These type of scores are not used very much because they don't give us a reference point. They don't give us something to compare to. And that's what we're looking for, especially when we talk about state test scores. Not only do we want to compare our scores, our school scores, our class scores with others, but we want to compare them with other similar schools or other similar demographics. So we're not comparing Scarsdale with a school of low poverty, which doesn't make sense to do that. So the type of scores are derived scores, which are where raw scores are converted, and they allow us to make a comparison. So developmental scores, all of us are used to those. If you've done running records or any kind of reading assessment, you'll get an age or a grade equivalent. A student is reading at the 4.5 for fourth grade, fifth month level. So we're all familiar with that. A developmental quotient, I'm not even going to go into that. It's like an IQ, but it's based on chronological age versus the achievement. And there are scores of relative standing, again, percentile, standard scores, and Stanines. Not going to talk about those either. I'm going to talk about age and grade equivalents because we use those all the time. And these are norm reference tests that give us these kind of scores. And when I say they're good for screening, it's because we can see a student that's entering kindergarten, if he's reading on a first grade or second grade level, that gives us a good idea of where he's at. If the student is reading at a lower than a kindergarten level, then we know that we need to do something about that. One of the things that we need to keep in mind, though, when we use age and grade equivalents is that you can't expect kids to gain a year each time on a test, because the test, typically they are extrapolated or interpolated in between certain levels. So if something is fourth grade, 8 months, that's usually been an interpolated score. It's been it's a guesstimate. So we got to be careful about that. And it's also dangerous to compare student scores because everybody develops at a different rate. So I remember my own son who they wanted to keep back in kindergarten, and because of one of his grade equivalents wasn't where it should be, and it turns out he was just developing slower than everyone else, and he caught up in the first grade. So we have to be careful about that. One of the things that's really bad about grade equivalence is that sometimes parents will go in and hammer away at you and say, my student's in the 5th grade reading on a 7th grade level. I want them in the 7th grade. And that's not correct at all. So we got to be careful when we're using grade equivalents. Percentile rank is another one where most of us have heard. I know that's one I remember being told. I was in the 80th percentile or 85th percentile, which means that if I'm in the 80th percentile, I've scored better than 80% of the students that have taken this test. So that's the standardization sample again. Of 80% of I did better than 80% of those kids in that standardization sample. So another comparative score. These scores, Z-scores, T-scores, deviation, IQ, STAY-9, normal curve equivalent, percentile rank, I'm not even going to go into those. They are just different ways to represent the normal curve. So I put this here so you can see where that would be. And, I think STAY-9 is dividing the normal curve into 9 sections. And I'm not sure who or what, when that would be used. I haven't heard a lot of it. This is one of your vocabulary words, standard error of measurement, and it's the amount of error associated with the test scores. Items, samples, times, poorly worded questions, kid comes to school not feeling well. All those are built into this in testing with the standard area measurement. So what we get from it is the probability that an individual taking a similar test will get the same score. So it has to do with individual reliability. It's really a form of reliability of an individual's test score. Confidence bands are the range within which a test score can fall. This is used in research all the time. We have a 90% confidence band that if a child scores, a test score will fall in the range of 83 to 89. So it's something to think about. The last couple of things I want to talk about have to do with our discussion board, and one of them is that many of you will react strongly, many of you will react strongly to a lot of things in this discussion board about standardized testament, but when you read Harder Than the Dickens, and they talk about the care that goes into creating tests, one of the things they mention is that it could cost up to $1,000 a question. And because of all the work they have to do, the sampling and the pilot testing and then throwing it out and checking it for bias, et cetera, et cetera. So in the long run, it could cost a lot of money per question. So a lot of you say, we could spend that money on iPads or whatever. But the fact of the matter is that while it may be overall testing in the United States may cost $1.7 billion, according to the article Strength in Numbers that I have in course materials, which you should check out. At least you should scan it for important information. And if you say, oh my God, it's $1.7 billion. My goodness, I could use that money. Yeah, I could too. And the cost per state varies. Hawaii spends $100 per student, while Oregon spends $13 per student. And it varies based on the size of the state. Like New York State is probably between the $13 and $20 range because of the size of our state, and that we can service more kids with the same test, which is one of the reasons many people want to see a national test, is because it'll take a lot of that pressure off a state like Hawaii, Rhode Island, Delaware, small states that have to make one test for just a small number of kids. So the real figure that you need to look at is the overall relative cost of it. This amounts to 1/4% of overall K through 12 spending. So you won't be able to buy much for 1/4% of your school district's budget. So keep that in mind. I just wanted to introduce you a little bit to the new Common Core state standards test. One is, there are two main consortiums. One is the Partnership for the Readiness for College and Careers, and the other is the Smarter Balanced Assessment Consortium. I'm going to talk more about PARC, because that's what New York State is looking at. And I have, you can go to the New York State website. I have it here on Common Core Assessments. And they talk about Parks frameworks because they agree with that. That's the one they like. They say that they're not sure that they will be adopting their test, but right now that's the one, the group that they will use if they use one test. So that's something. So that's why I'm talking a little bit about it. It will be computer-based. Now, computer-based assessment is one that when I took my GREs, I went to a Sylvan Learning Center, and I could pick the time of day I went. I think I went in the morning, and the computer-based test, if you get 2 or 3 in a row right, then it cycles you up. If you get 2 or 3 in a row wrong, it cycles you down. So what's good about it is it automatically modifies the test for, say, a special needs student who may struggle with certain questions, but you are going to get questions that that student will be able to answer. So one of the difficulties with that is now we're going to have to equip schools with computers. We have to make sure that they are all equipped with computers in order to do this. I've put a link here to the modified model content frameworks that they use, and I have that here, Park Model Content Frameworks, and you can go through them. ELA Math for grades 3 through 12, I believe. Maybe it's just 3 through 8. But these are something to look at because if we do, New York State does go that way, we're going to have to know these. So that's it for this session on standardized testing. I wanted to show you this map here. I forgot to do it during the last video, but this is from Cohen and Spencer, and it's page 92, and it shows you the Peabody Picture Vocabulary Test, which is a norm reference test, and many elementary school teachers are familiar with this because it's good for assessing vocabulary of students that are not real verbal yet. But anyway, this shows you these dots are where the test was given throughout the United States. So I thought this was an interesting way to show you how a sample population is developed. And you can see there's nobody in Montana or or Idaho. Oh yeah, Idaho has some, but that have there's because that they don't see that as being the typical student. So that's it for this session. I will see you in a couple of weeks.